Hello everyone, my name is Daria and I'm going to present to you my work planning and prototyping digital twin for educational buildings. Actually. As for introduction, I want to mention the main stages. It was literature review, overview of solutions for digital twin planning, where I used such software as Dalux Field, Plannerly, and Revit, and digital prototyping, where I used Tandem, Autodesk Tandem. So first of all, as for literature review, I made a review of scenarios for digital twin. Here you can see scenarios for end user welfare, such as occupancy management, real-time monitoring of environmental conditions, adjusting of environmental conditions as predictive maintenance, emergency and safety, and navigation assistance. All of them lead us to comfort, efficiency, and safety for end users. As for next step was scenarios for energy consumption, reduction of energy consumption, where you can see building energy management, occupancy and space utilization, water management, lighting, and lighting management. And as an example, you may see a picture of integrated lighting and a light control scenario right here. Also, as a part of literature review, I reviewed indoor characteristics which can be measured by IoT sensors. It includes indoor air quality characteristics such as temperature, relative humidity, carbon dioxide level, occupancy, lighting, opening, closing of blinds, windows, doors, and energy and water consumption matters. As well, here you may see in the picture example of impact of carbon dioxide on human decision-making performance, which is crucial. As a part of overview of software and hardware for digital twins, I reviewed such software as Autodesk Tandem, Dalux Field, Ecodomus, which were acquired by Siemens, Nexus Twin, and several smart building cloud platforms, as well as time series databases. I chose for next steps Autodesk Tandem and Dalux Field. As for Dalux Field, it was proposed by my supervisor, and as for Tandem, it is well known in the market, and I decided that I want to test it and implement my solution with help of it. As for hardware for digital twin, I reviewed generic types of sensors, such as by this I mean how to measure specific characteristics by specific types of sensors, as well as communication protocols and network technologies. As for specific types of sensors, I just reviewed several of them. Mostly I oriented on on-set hobo solution just because again my supervisor proposed it. Also a good wait a second, I will try to mute. No, I can't. Okay, it's better. So yes, I chose on-set hobo solution, also because it has a good integration with a smart building cloud platform, a hobo link. Next thing is a case study. As for case study building, it was chosen hydrology and hydraulic engineering building of Faculty of Civil and Geodetic Engineering of University of Ljubljana here in Slovenia. It is a three-storied building with several classes, offices for teaching staff, and laboratories. As for pre-existing status, it already had some sensors, but all of them couldn't collect data. They only recorded for 24 hours without any savings in databases. And as for building characteristics, I also reviewed MEP systems, building envelope, and so on. Also, my supervisor provided pre-existing as-is model, as you can see here in the screen. With help of this model, I made several steps. I will show you later. Here, I conducted a survey of the building with help of Dalux field software. Here it is shown as build checks. For instance, I made checks for each room in the building and put some comments, as you can see, like which actions is required. Here it is, I need to add furniture, radiator, lamp, vendor machine, and so on. Also, you can see that I attached, I took photos of each room as well, and I attached it to each as build check. Also, as a part of a survey of the building, I made 360 photos. Here you can see the real situation from 360 photo and comparison with as-is model. The connection between 360 camera and Dalux field is super smooth. For these purposes, it is already connected, and I only run the software and attached camera for further capturing photos. The next step was to prepare a model and a BP for this model. For these purposes, I used Plannerly to prepare a LOD table, as you may see as well in the screen. I want to show you as is and to be model. As is, it is it is a pre-existing model which I took, which my supervisor gave me, and to be, it was made with help of Revit software, and you can see it in more detail here. So I use a BEP. No, I use a LOD table as a base for further development of the model. Again, some examples of process of modeling. I already showed you this photo of real situation as this model, and here the same room, but in to be model. Also part of the process was sensor placement strategy. Here I used Dalux field for these purposes, and as an example, for air quality control sensors, I placed in a specific height. It was a rule to place it in a distance from walls, avoid environmental factors such as direct sunlight and so on. again I checked wall obstacles and avoid external walls. Yeah, it is kind of an example. Also, economical calculations were made during this process. So the workflow of case study can be presented like this. I prepared BEP plan. The model was updated to in a good in a high LOD level. And also sensor, since I've made a sensor placement strategy, I can put all this data to Autodesk Tandem for further digital twin prototyping. So here you can see sensor placement. I used, it is model from Revit and the sensor data from Dalux, as I told you before. And for generating data, I encoded JSON and sent data with help of Postman app to each sensor. Then you can see that for sensor number one, we have data for carbon dioxide, relative humidity, and temperature in that graphs, which is represent the data. And the last step was creating a heat map, heat maps. Here you can see heat map for temperature. It is kind of a sensor data visualization for better understanding the situation, like whereas the conditions is bad, whereas it is normal, and so on. So the main conclusions of the work is that market is ready for digital twin in building management, and in specific for in educational buildings. The main benefits for academic buildings, it is that we can control, we can reduce energy consumption and costs as well, and create more, create better learning environment. Real-time data from IoT sensors can provide some insights for us for again better facility management processes. And also, I would say that for these purposes, it would be better to hire data analysts and people who will provide accurate data for digital twin, just because the maintenance and operation processes is in process, so somebody should update data all the time.